Have you ever wondered how those enormously popular, flawless, flaky, buttery croissants are made? Come along with us as we give you the tour of a croissant factory behind the scenes. We'll reveal the methods used in creation of industrial croissants, from the first combining of components to their last packaging. Prepare to be astounded as we delve into the intriguing realm of croissant production. Now, let's get started. The first step in croissant production involves preparation and mixing. Specialized mixers designed for industrial scale production handle this crucial stage. Here, the process begins with forming a pre-dough. This involves combining flour, water, in-dough fat, yeast, salt, and sugar in a single step. Croissant pre-dough is typically mixed in a cool environment for a longer duration compared to other pastries. These commercial mixtures have strong motors and durable mixing mechanisms that guarantee complete ingredient incorporation and uniform dough texture. The entire mixing procedure is meticulously regulated, with changes made to variables like speed and duration of mixing to get the exact elasticity and texture needed for the best possible dough quality. About 19 degrees Celsius is the ideal dough temperature for the ingredients to be hydrated as best as they could be. Interestingly, compared to mixing bread dough ingredients, croissant pre-dough is considered underdeveloped. Mixing is stopped as soon as the dough appears homogeneous to allow for further dough development in the next step. Lamination is essential for creating multi-layered dough with altering layers of pre-dough and fat. There are generally two methods for folding fat into the dough, the English method and the French method. In the English method, one fold results in 2 flat layers and 3 dough layers. After spreading out the pre-dough, the roll-in fat is flattened to a similar thickness and spread over 2/3 of the laminated pre-dough surface. Rolling and folding are crucial steps in croissant production for creating the characteristic flaky layers. At this stage, industrial dough sheeters play a pivotal role. These specialized machines efficiently roll out the dough into thin, consistent sheets designed to handle large volumes of dough, ensuring high productivity levels in a factory setting. Dough sheeters maintain a uniform thickness and offer flexibility with precision rollers and adjustable settings, ensuring consistent dough products and accommodating specific recipe needs. By using industrial dough sheeters, factories can streamline the rolling process while achieving the precise texture and layering required for high-quality croissants on a large scale. Croissant dough is typically laminated until it obtains 60 to 50 fat layers. The optimal number of layers can be determined by balancing certain crumb properties with specific volume. A low number of layers results in a large specific heights and an irregular crumb structure with large voids. Conversely, a large number of relatively thin layers leads to interconnections between different dough layers and less dough lift. Moving on to the next step, we have the cutting process. When handling dough sheets on a large scale, they are guided through rotating blades that carefully trim their sides, ensuring clean and uniform edges. This meticulous side cutting not only enhances the final product's appearance, but also guarantees consistency for subsequent steps. At this point, specialized machines equipped with cutting tools refine the dough by slicing it into classic triangular shapes, perfectly tailored for the iconic croissant. The next step is the filling process. Once the dough is shaped into triangles, it passes through a machine equipped with small injectors. These injectors are designed to dispense various fillings or flavors into the center of each dough piece as it moves along the production line. From indulgent chocolate cream to fruity jams, the fillings injected into the croissant dough offer a range of sweet options. As the dough moves through the machine, a rotating blade delicately lifts and curls its edges, initiating the rolling process. Concurrently, the dough is covered with a soft substance, usually silicone or food-grade plastic, to keep it rolling and keep it sticking to the conveyor belt. Together, these components give the dough its traditional croissant shape, which is a crescent. The process of shaping comes next. Revolving wheels or side rollers gently push the dough as it rolls down the conveyor belt, effectively forming it into the required shape. Robotic arms with grippers or paddles may do the shaping task in increasingly complex configurations. These robotic arms lift and move the dough pieces precisely, guaranteeing consistency in both form and appearance. After the shaping process is completed, the next step is to color and flavor enhance it. Factories give customers a range of alternatives by using different ways to add different colors and flavors to the dough. For chocolate croissants, one way is to incorporate ingredients straight into the dough, like cocoa powder or melted chocolate. As an alternative, manufacturers can add color to the croissants by naturally coloring them with fruit juices, vegetable extracts, or spices. They can also decide to add chocolate chips, nuts, seeds, or sugar crystals to the croissants to improve their flavor and texture. The next step is the fermentation process. What sets croissants apart from the other puff pastries is the yeast, which gives the dough more volume while it proves. The ideal yeast level for croissants is 7.5%, and the ideal proving period is 60 minutes at 31 degrees Celsius. The dough for croissants is deemed properly proved when it has doubled in bulk from what it started with. The fourth step is the baking process, also known as pastry lift or dough lift. The dough expands as the water converts to steam, increasing pressure between each dough layer. As a result, the croissant dough rises and acquires its distinctively flaky texture. Oven temperature settings range from 165 degrees Celsius to 205 degrees Celsius, and baking times can be anywhere from 10 to 20 minutes, depending on the type of oven and croissant size. Croissants are put into sizable trays for rapid, extensive baking. The trays have specific shapes to hold each croissant and prevent shape loss during baking. These trays are then placed in the factory's large ovens, which is advanced rolling and rotating systems for even baking and consistent heat distribution. This results in a perfectly golden brown croissant with a flaky texture. The controlled movement of the trays within the oven optimize the baking process, enabling efficient production of high volumes of croissants while maintaining quality standards. Moving on to the next step, advanced robotic arms sort and handle freshly baked croissants with precision. Equipped with cutting-edge vision systems and machine learning algorithms, these robots accurately identify and select croissants from conveyor belts. Using this technology, the robotic arms analyze factors like size, shape, color, and texture to effectively group croissants for packaging. By choosing croissants with similar shapes, factories ensure consistency and appearance in each batch, maintaining the uniformity and visual appeal of the final product. The next step is packaging. After sorting, croissants move onto various conveyor streams based on their characteristics for effective packaging. Additionally, these systems can inject flavors into the baked croissants using precise tools that create small holes without affecting their structure, allowing for flavorful fillings to be injected. Specialized machinery automatically wraps croissants in plastic before packaging. High-speed flow wrapping machines are commonly used and equipped to handle rapid packaging. Conveyor belts transport croissants into the packaging area, where they are automatically fed into the wrapping machine. Inside the wrapping machine, a continuous roll of plastic film wraps around the croissants as they move onto the conveyor belt. The film is sealed and cut around each croissant, creating tightly wrapped packages. Automated sensors ensure precise sealing. Advanced machines may include features like gas flushing or vacuum sealing to extend shelf life by removing oxygen or adding inert gases. Robotic arms that handle the packaged croissants automate the distribution procedure. These robots can pick up croissants from conveyor belts and place them into enormous carton boxes with efficiency because to their sophisticated sensors and precise grippers. As the croissants travel along the conveyor belt, the robotic arms quickly recognize and seize each wrapped croissant, carefully arranging them in carton boxes to maximize space and reduce waste. For the efficient delivery of freshly packaged croissants to stores, supermarkets, and other locations, these automated methods are essential. They meet consumer demand with precision and reliability, ensuring that the croissants reach their destinations promptly and in top condition. Exploring croissant production has been an exciting journey through the world of baking. Every stage, from combining components to forming and distributing, is vital. We have looked at every step of the complex industrial croissant production process, from the first mixing of materials to the last packaging. It is an intriguing trip that blends cutting-edge technology with the age-old baking methods. Was this video informative to you? If so, kindly subscribe and give it a thumbs up for more exclusive behind-the-scenes glimpses into the production of food. Are you curious about different methods used in the production of food? What should we see next? Tell us in the comments section below. Thanks for watching.